Hello everybody, this is Saswat and today we're going to talk about the lunar eclipse that happened on September 9 and 10. So why am I making this video? The crazy reason is that I went to moon, I saw the moon, and I'm making this video about moon right now. You might be asking, Saswat, how did you go to moon? Only 12 people have touched the surface of the moon and you're flexing that you have gone to moon? That is not even possible. We're not going to believe you. um, Sorry guys, I actually went to moon and see this. Here is the proof. I won the best delegate award too, and the reason I'm making this video is the moon itself, because otherwise, no, the thing is, I should have made this video more than a month ago. I was in the committee WHO and universe sent me the frequency. Then, if not me, then who? If I'm not going to make this video about the lunar eclipse, then who? So that's the reason I'm making this video about the lunar eclipse. So welcome to the interesting astronomy concept, video 1. Let us get this started. So let me quickly get into this. Um, who the hell is this lunar eclipse? So, you know it. Lunar eclipse happens when moon enters the Earth's shadow. So, for example, you can see it right here that let's talk about this. Okay, this is the sun, and this is the Earth. You see it? So let me quickly actually do this with the green thing. Okay, this is the sun, and this is the Earth, and this is the moon. So what happens is when they align themselves in a straight path. This is a straight path. This assume that this is a straight path. Then the thing that happens is the parallel rays from the sun. They strike the Earth's atmosphere. Oh yeah. Let me get into the Earth's atmosphere. Oh yeah. Like this. And then most of the sunlight get absorbed by the atmosphere, and some of the sunlight which remain, let's say, strike the moon's surface and paint the moon's surface in the red. That is a lunar eclipse for now. This is the lunar eclipse for now. But actually, this is just an imaginary thing. What happens, I will tell you later, is let me talk about this. Let me talk about this thing first, which is why don't the eclipses happen every month? See, you see this and this. This and this is actually 5 degrees. Moon's orbit is not coincident to the Earth's orbit. Just imagine this. Imagine it. You need to imagine, guys. Astronomy, physics, anything is all about imagination. Thanks to Einstein, imagination is more important than knowledge. Imagination is very thing because without it, we can't create anything new. Wow, for Einstein. Clap for him. So let's imagine. The sun is in the middle. The earth is revolving around the sun. And then again, moon is revolving around the earth. Get that picture in your mind here. Then imagine that earth is in the middle of the moon and the sun. That's great. Sunlight is coming from the sun. Strike the earth's atmosphere, strike the earth, and then again sunlight go to the moon's surface. Wow, that's crazy. This is a lunar eclipse. So what happens? What happens is that moon's orbit is not coincident. What I mean by coincident is, okay, so let me quickly go right here. Quickly go right here. So suppose this is the sun, this is the earth, and you might think that, okay, this is the ecliptic, the thing that the path traced by the earth while it revolves around the sun, and then you might think that moon will be like this, and you might think that they are coincident, which is 0 degrees. The difference is 0 degrees between them, but that is not the case. That is not the case. Moon's orbit is actually inclined 5 degrees like this. Moon's orbit is inclined 5 degrees like this. Up, it is 5 degrees up here and it is 5 degrees down here. So make this imagination in your mind that the when moon goes here, when moon goes here, what happens? So let me tell you one thing before going there is that these are called the nodes. These are called the nodes. And at nodes, that is coincident right there, which is the ecliptic and the path traced by the moon while revolving around the earth are do not have any angular difference. Let's say let's keep it that way. And then the thing that happens right there is only when the moon is in the node that there is an eclipse. And I'm talking about that when the earth, moon, and the sun are in the same straight line. So let's paint this vivid picture, erase this hell of a thing, erase this hell of a thing, okay? Now what you need to do, what you need to understand is, okay, what you need to understand is this is the earth and this is it. Now what happens is, let's keep the earth from here to there. Suppose that earth revolves and comes to this point. This is the earth right here. Um, and then this is the revolving path, yes. And what happens is the moon, the moon, like this, and the moon is here. The moon is here, and the angular difference, the angle made by the ecliptic and the path of the moon is 0, which is that the moon is at its node. Moon is at its what? Moon is at its node. So moon is at its what? Node. So what happens is the sunlight go there. The sunlight actually go there, and then it strike the Earth atmosphere. It strikes the Earth atmosphere, and it goes to the moon and paints the moon red. And only when the moon is in the node that the eclipse happens. That is the reason why eclipse doesn't happen every month. So as we begin to conclude, let me quickly talk about what astronomers use to do some great scientific calculations. They use something known as contact points. So let's say moon has entered the penumbra. Before going to the totality, let me talk about this thing. Let me talk about the leading edge and the trailing edge. Leading edge which is ahead. Trailing edge is behind. So guess what is the leading edge here? Leading edge is this, and the trailing edge is this. So what I'm going to do, what the moon, as the moon revolves, as the moon moves, it comes here. That is C1, contact point 1. It has just touched the start of the umbra. Okay. Now, at this point, the partial phase begins. Now, as the moon moves, the leading edge goes ahead, trailing edge goes ahead, and what will happen? What will happen is moon will come here. Now, see this: the very trailing edge has touched the umbra. Now, the totality has begun. The moon is totally under the umbra. Partial phase has paused for now. Let's say. Now, what will happen as the moon moves through the umbra? It will come here. The leading is, again, the leading is has touched the exit of the umbra. This denotes that the totality has ended. This is known as C3, contact point 3. Now as it moves again, the trailing edge has touched the ending of the umbra. From here to here, partial eclipse had happened. And as the trailing edge touched the, let's say, as the trailing edge touches the exit of the umbra, the partial phase has ended, partial eclipse has ended. And let me quickly phrase it as this: astronomers use these contact points C3, C1, C2, C3, C4. And you might be asking, how do they find the duration of totality? They say exact time, this and that. I've shown it on the screen as well. You can see that. Um, they calculate the linear distance traveled by the moon through the umbra, through the penumbra, through the umbra, and they divide it by the moon's orbital velocity, which is, I've written it here, what is this? Okay, 1.0222 kilometer per second average speed. And as we divide distance by the velocity, we get the time, right? In 4 minutes. We are not going to do the calculation right here. We need the center of set, we need the umbral radius, we need the moon radius, and things like that. We might be covering it in the later upcoming videos, but that is how they calculate it. I think, guys, this was it for today. And yes, uh, if you have more questions about why the moon looks red, it is covered by the topics of like the Rayleigh scattering and things like that. Those are the reasons, as the the sunlight passes through the thick Earth atmosphere. They turn into longer wavelengths and they paint the surface of the moon red. And that's a lot about the Rayleigh scattering and things like that. We might be covering it in the later video again. This was it for today. Hope you liked the video. Make sure you like, comment interesting things, comment interesting questions. Yeah, that was it for today. Meet you in another video. Thank you.